Good morning, dear students. This is chapter 4, Structure of the Atom, and I'm here with part 2 of this chapter. Okay, so let me show you what we are going to discuss in this part. In this session, we'll discuss about Rutherford's model of an atom and then drawbacks of Rutherford's model. Okay, E. Rutherford was born on 30th August 1871 and he is known as the father of nuclear physics. He is famous for his work on radioactivity and the discovery of nucleus of an atom with a gold foil experiment. And he got the Nobel Prize in 1908 in chemistry. Here you can see the picture of Rutherford. So now let me start. What is Rutherford model of an atom? Actually, after Thomson model of an atom, many scientists came up with their theory and with improvement in that model of Thomson atom. It was Rutherford who came up with the ideas of nucleus, that inside the atom nucleus is there. And he was very much interested in knowing about the arrangement of electrons within the atom. So he designed an experiment for that, and his experiment is world famous. He did this experiment with gold foil, and in his experiment, what did he do? He made fast moving alpha particles to fall on thin gold foil. This was his experiment. And do you know why did he select a thin gold foil? He selected gold foil because he wanted as thin a layer as possible. That is why he selected thin gold foil. And the gold foil he selected was about 1000 atoms thick only. Right? And the next topic is particles that are doubly charged helium ions, means they were positively charged particles. Those particles have a mass of 4 unit. So those fast moving alpha particles have a considerable amount of energy. Okay, and it was expected that particles would be deflected by subatomic particles in the gold atoms. Okay, since alpha particles were much heavier than the protons, he did not expect to see large deflections during his experiment. So these 3 points he considered when he was going to start his experiment, right? First one, he took alpha particles. And why did he took alpha particles? Because they were positively charged particles. And he took gold foil. Why? Because he wanted a very thin layer. And third one, he was expecting sub deflection in the particles, right? Okay, these are the alpha particles. These are the alpha particles, right? These. And these are gold atoms. When these alpha particles were bombarded on these gold atom particles, what do you observe here? See, you can see some of the particles, they are passing through gold atoms directly as they are, right? You can see here, these particles are passing. Okay, and some are the particles, they are deflecting from their path. This is the second point. And very few particles are coming back to the same path. So these 3 points he noticed. Now, so what was his expected result? Before the experiment, he expected that alpha particles passing through the plum pudding model that was given by Thomson. ठीक है? So these alpha particles passing through the plum pudding model of the atom undisturbed. Okay, so he expected this. Okay, all the particles will pass. But after the experiment, what did he observe? He observed that a small portion of the particles were deflected. And what does it indicate? It indicates a small concentrated positive charge. Okay, this is. So, before the experiment, whatever was expected by Rutherford was not observed in the experiment. He expected that all the alpha particles will pass through the atom, right? But during his experiment, he noticed that some of the particles are passing through this, some of them are deflecting, and some are coming back to their path, right? This is the animation of scattering of alpha particle by Rutherford. Okay. Here, this is another angle of same experiment. These are alpha particles that you can see over here. They are passing through the gold foil, and after that they are deflecting, and some are coming directly, that you can see. Okay. So what was the observations made by Rutherford? His observations were, the first one is, most of fast moving alpha particles passed straight through the gold foil. Okay, this is first observation. Second observation is, some of the alpha particles were deflected by the foil by small angles. Okay, and third observation was, one out of every 12,000 particles appear to rebound. These three very important observations made by Rutherford during his experiment. Let me show you these observations in this animation. The first one is, most of fast moving alpha particles pass straight through the gold foil. Okay, these are the particles, they are going straight, right? The second one is, some of the alpha particles were deflected by the foil by small angles. So here you can see these are deflection, these are the deflection. Okay, and third point was, one out of every 12,000 particles appear to rebound, means it is coming back and it is going in the same path. These three observations were made by Rutherford, right? So now, in the word of Rutherford, if I say, the result was almost as incredible as if you fire a 15-inch shell at a piece of tissue paper and it comes back and hits you. Mean to say is, Rutherford was very surprised by the result he achieved after this experiment. Okay, so by his observation, he concluded some point. Let me tell you the conclusions from the alpha particle scattering experiment. The first conclusion was, see, most of the space inside the atom is empty. This was his first conclusion. The very important point made by Rutherford was that inside the atom, most of the space is empty. And why did he made it? He make it? See, because most of the alpha particles passed through the gold foil without getting deflected. It means inside the atom, most of the particle is empty. Okay, if this is the atom, so inside the atom, most of the part is empty, right? Because so many alpha particles are passing straight. Now let me come to the second point. Before that, let me rub it. Okay, now I'm coming to the second point. Okay, here I'm having the second point for you. Very few particles were deflected from their path. And what does indicate? It indicates that positive charge of the atom occupies very little space, right? See, alpha particles are positively charged particles. Okay, when they are entering the atom, some of the particles are deflecting from their path. Means the same charge is the reason for this deflection, because same charges repel each other. But number of particles that are deflecting are very few. It means the positive charge inside the atom occupies very little space. This was the second point. And the third point was, a very small fraction of alpha particles were deflected by 180. Means at the same path, those are coming back, right? So very small fractions of alpha particles were deflected by 180. It indicates that all the positive charge and mass of the gold atom were concentrated in a very small volume within the atom. and that small volume was named as nucleus. So I think it is clear. 3 observations were made by Rutherford during his experiment, and on the basis of those 3 observations, he made 3 conclusions. These are 3 conclusions. He said most of the space inside the atom is empty. Okay. And positive charge of the atom occupies very little space. This is the second point. Okay. And the third point was the positive charge and mass of the atom were concentrated in a very small volume within the atom. Right? So, from his observation and the data, whatever he got after his experiment, he calculated that the radius of the nucleus is about 10 to the power 5 times less than the radius of atom. Okay, so nucleus is very small inside the atom. So on the basis of his experiment, Rutherford put forward the nuclear model of an atom, and his model has following features. The first point is there is a positively charged center in the atom that is called a nucleus, and nearly all the mass of the atom resides in the nucleus. This was the first point of his model of an atom. And the second one was the electrons are revolving around the nucleus in circular paths. Okay, and this is the third point. He said that the size of the nucleus is very small as compared to the size of the atom. So this is Rutherford's nuclear model of an atom. At first he did his experiment, then he made 3 observations. On those 3 observations he made 3 conclusions, and then he put forward his nuclear model of an atom. These 3 features are of nuclear model of an atom by Rutherford. So it was a great success by Rutherford, but Rutherford model also has drawbacks. As I told you, it was a revolution that he told that electrons are revolving around the nucleus on a circular orbit inside the atom. Okay, but electron, when it is in motion or it is revolving around the orbit, it is not expected to be stable. Why? Because any particle in a circular orbit would undergo acceleration, right? And when it would undergo acceleration, then what will happen? Charged particle would radiate energy. Okay, so it will keep on radiating energy, and then the revolving electron would lose all the energy, and finally it will fall into the nucleus, right? So the electron will destroy. So how atom is stable? Rutherford could not explain. So this was the major drawback of Rutherford's model of an atom. Okay. So as I told, if electron would keep on losing energy, it will fall into the nucleus, and then atom should be highly unstable. Okay. But now we know atom is stable. So stability of the atom could not be explained by Rutherford nuclear model of an atom. Okay, so these are the drawbacks of Rutherford's model. Rutherford atomic model could not explain how the moving electron could remain in its orbit. Okay, actually when electron is moving on a circular path, it will lose energy. Let me rub this. Right. Okay, now let me do it again. Yes, it will lose energy, and it will lose energy, and finally what will happen? It will fall down in the nucleus. So Rutherford could not explain how the moving electron is stable in its orbit. And the second drawback of Rutherford model was any charged particle during acceleration would give out energy, and while revolving it would lose energy and eventually fall into the nucleus. Right? So this is the picture of Rutherford world famous gold foil experiment. These are alpha particles. These are positively charged. That is gold foil. Okay, and these alpha particles are passing through it. You can see most of the particles are passing straight. Some are getting deflected and very few are coming back. And very few, what do I mean by very few? 1 out of 12,000 particle is coming back. So what was the observation made by Rutherford? He observed that most alpha particles travel through the foil undeflected, means straight. Some alpha particles are deflected by small angles. And the third one is on alpha particles, means very few or 1 out of 12,000 alpha particles travel back from the foil. So these were the observations. And what was the interpretation made by Rutherford? It was the atom is mostly empty space. The nucleus is positively charged. Okay. And the nucleus carries most of the atom's mass. So these three features were there in Rutherford atomic model. So in this session, this much was there. I hope you liked it. You can go through again by this session and read the chapter once again. And if you have any doubt, we'll meet in live classes. There we'll solve all your doubts, right? So now we'll meet in part 3. Thank you, students.